All right, so here's our I can statement. Our I can statement is going to be a little bit longer than normal, okay? So bear with me. I can reason using benchmarks to compare two fractions on the number line, okay? So today we're going to do two fractions, but I'm going to actually start off with three, all right? Just give you an example of what we're talking about, okay? Benchmarks are things like zero. I know what a zero is. Zero is nothing. One is a whole number, right? And I know half. Half is just splitting something into half, all right? And I can compare two fractions about which one is bigger than the other. I can compare them like greater than or less than or equal to by using a number line. So how are we going to do that? So what I'd like you to do is grab your template. This should be the next page after your exit ticket. This one right here, okay? So whether you're, the kid that keeps all the papers together in a booklet or the kind that rips it out, you need to have this in front of you, okay? All right, so we're going to take a look right here at the top. It says application problem. And you're going to write down a couple of fractions for me at the top of this, okay? So first of all, we're going to write in 1/4. Then we're going to write in 4/5. Put a little comma there so we know we're separated them. And then we're going to write 5/8, okay? All right, so now here I have a nice number line. Okay, get 0, 1, and a half. Okay, so there's my benchmarks that we just talked about in our I can statement. 0 is the bottom of the number line, 1 is the top of the number line, and a halfway is halfway between it, okay? So now what I want to do is estimate about where these would land on a number line so I could tell which one's the least amount and which one's the greatest, okay? So I'm going to start off with 1/4. And I know 1/4 is less than a half, because I know that 2/4 would be exactly a half. Does that make sense? Because if I look at the denominator is how many pieces the whole is. And if I have exactly 2 out of the 4, I have exactly half. Well, if I have 1/4, that's lower than a half. So that 1/4 would be down here. So I'd plot that 1/4 right there, okay? So I know that would be on the number line there. Now look at 4/5. Now, 4/5 is almost the whole thing, and I want you to think about that for a minute, okay? If I have a number line like this one, split up into 5 pieces, and I have 4 of them, aren't I going to be above 1/2? Aren't I going to be up here somewhere? Because I'm only missing a small piece of it, just 1/5 of it, okay? Plus, half of 5 is, 2.5, right? And 4 is bigger than that, so I know I'm past the halfway point. So 4/5 would be up in this area somewhere, okay? So I got that one taken care of. Now I got 5/8. And this one I like because 8ths is a nice even number. And I know half of 8 is 4. So 4/8, if I had 4/8, I'd have exactly half. Well, this is 5/8, so it's just a tick higher than 4, isn't it? So I know that 5/8 would be in here somewhere, right? Just like that. So now I know by using my benchmarks and what I know about fractions already, where these would line up on a number line. I know that 1/4 would be the lowest. I know that 5/8 would be in between, and I know that 4/5 would be the highest. All right, I hope you understand that concept pretty well. All right. Now we're going to take a look at our concept development. We're going to move right into that, okay? Let me turn my page over here. Okay. So we're going to reason about the size of the fraction compared to a half. So here's a half, okay? So how many sixths equal 1 whole? How many sixths equal 1 whole from 0 to 1? All right? That would be 6, right? So what I'd need to do is split this line into 6 pieces. So I can do that, all right? I know half of 6 right here. This would be 3/6, wouldn't it? So if I cut this into 2 pieces there, and this into 2 pieces here, wouldn't I have 6 pieces? 1, 2, 3, 4, 5, 6. And I know that 2/6 would land right about here. And I know that's less than 1/2, right? Because 2/6, I know that the exact halfway would be 3/6. Does that make sense? So I know it would be less than a half. Okay? So I'm just comparing it to a half there. It'd be a less than a half, okay? I hope that, does that make sense to you? I hope so. All right, let's just do another one. Let's try the fraction of 5/8. So let's do this, 5/8. All right, now let's just take a look at this line as a whole. Where would 5/8 land on this number line? I'm not even gonna write any of the tick marks in. Where would it land on this number line? And I have to think about 1/2 as my benchmark. So if this is split into eighths, wouldn't 4/8 be exactly the center? So I know 5/8 would be somewhere in here, wouldn't it? So I know 5/8 would be greater than a half. Yeah, that makes sense, right? So we see how that, so if I were comparing 2/6 and 5/8, I can compare it by what I know about 1/2. 2/6 is just a little bit less than a half because 3/6 would be exactly a half. And I know that 5/8 is a little bit more than a half because 4/8 would be exactly a half. All right? That makes a little bit of sense to you. All right, how about this one? How about 2/3? Let's find 2/3 on this number line and let's relate it to the benchmark of 1/2. All right, so what would half of 3 be? That's an interesting discussion. Wouldn't half of 3 be 1.5, right? So 2 would be higher than a half. It would be up in this area somewhere, wouldn't it? So now 2/3 as related to a half would be greater than a half. It'd be closer to this, closer to 1. You know? Good. So now if I'm comparing 2/3 to say the fraction of, let's do 3/7, okay? Now what I want to do is reason about a half. What would half weigh between, what would half, if I have this cut into 7 pieces, what would half of 7 be? Well, it's an odd number. I can't really divide it in half, right? So 4/7 would be greater, but 3/7 would be less, wouldn't it? 3/7 would be down here somewhere. So I know if I'm comparing 2/3 and 3/7, you know, I know that 2/3 would be greater than 3/7 because I'm relating it to 1/2, okay? And we're just not going to bother with the bottom one here, okay? So really important to know that you can use benchmarks on a number line to compare fractions, okay? So today in our problem set, that's what we're going to do. All right, so hang tight. We'll be right back with that problem set.